And when we saw that, the results of the first year, we said, it can't be true. It can't be true. We have to continue one more year to examine more men to see if there had been some kind of bias or something like that, because we really didn't dare to believe in the results.
For us, the real shock was the first couple of years. In fact, we didn't even believe the first study. We put the chemicals on incredibly low concentrations, part per trillion concentrations. We got sex reversal. And we said, no, something's wrong. So this doesn't, we don't believe this. We repeated it the next year, got the same results.
In our modern world, we have 85,000 chemicals in commerce, most of which we don't know anything about. We don't know their carcinogenic potential, their reproductive potential, their effect on our immune systems, on our metabolism, and so on. So we need to get busy and start understanding what we're being exposed to, because we're all in this massive experiment, if you will.
For the last 50 years, our environment has been invaded by new chemical molecules. Could they be affecting our ability to reproduce? This is a question currently bothering scientists from a whole range of disciplines: zoology, biology, toxicology, cancer research. They've all been shocked by experimental results which seem to indicate that the hormonal systems of living creatures are under attack from chemical molecules. It's a bold hypothesis, bold and controversial, and it undermines several scientific certitudes. If these scientists are right, we'll have to rethink whole areas of the way we currently live. The idea is as provocative as the challenge it poses is serious.
In my opinion, the male reproductive health problems and the infertility problems that we are facing now are so important that potentially they are as important as global warming.
Our story begins in the early 1990s at the University Hospital of Copenhagen. Niels Skakebak, doctor and researcher, began to notice an increasing number of cases of testicular cancer and sterility. Skakebak posed the question, could there be something seriously wrong with the male reproductive system? He set himself a large-scale research project. In the library basement, Skakebak waded through registers going back to the 1930s and read over 60 surveys carried out all over the world. The conclusion he reached was edifying, to say the least. In 50 years, the number of spermatozoids in the male population had decreased by 50%.
It was certainly not what I expected to be, because the conclusion of the previous publication had been that there should be no decline in semen quality. So I was very surprised that we found such a significant decline. There were all sorts of controversies. Some people felt we had been using wrong pipettes, and others challenged the statistics, others challenged the method, the selection of papers, and so forth.
The backlash was fierce. The Danish scientist was attacked, and doubt was cast on his professional credentials. To be validated, his study would have to be confirmed by a second party. Skakebak transmitted all his references and documents to a renowned researcher commissioned by the American Academy of Sciences.
It seemed a big decline, 50% in sperm count in 50 years. It seemed implausible. If you think about continuing that decline at that rate, it's pretty alarming. So it was important to decide whether it was true or not. We made a very systematic analysis of each of the studies that went into this, and this took 4 months, and 3 people working for 4 months. I was very surprised that after all that work and everything we did, that we should come up with almost exactly the same overall decline that had been published.
In Paris, despite everything, the prevailing mood was one of scepticism. Yet whereas Skakovac had had to work with disparate materials, in Paris there was a sperm bank with very precise data.
On s'est dit, on va analyser nos données, ça portait sur plus de 1300 hommes, si je me souviens bien. Et au départ, on partait, nous, avec l'idée qu'il n'y avait pas de modification à la qualité du sperme. Et qu'on allait démontrer que sur 20 ans, dans une ville comme Paris, il n'y avait pas eu de changement. C'était un peu notre idée de départ.
The Parisian donors are all from a similar background, and all are fathers of at least one child. Their files, all perfectly documented, are kept in the centre's archives. Because of the exactness of its data, the study would become a reference work of international importance. The conclusions were alarming. In 20 years, Parisian men's sperm counts had decreased by almost 40%, or nearly 2% per year. Whereas in France, Pierre Joannet didn't have the funds to pursue his research, counting sperm isn't science, he was told by the ministry, the Danish authorities took the problem a lot more seriously. For if the drop in sperm counts proved to be an ongoing phenomenon, a population's entire ability to reproduce would be at stake. In 1996 then, the Danes launched an observation program, using 400 volunteers per year. The results are far from reassuring. One young Dane in 5 has a very low sperm count, low enough to have an effect on his fertility. Watch the sperm of this young donor and compare it with high-quality sperm. There are fewer spermatozoids. They're less mobile. Some have 2 heads.
It concerns me, not just because of there are too few people being born in Denmark, but also it is of concern that something actually hits the humans that we don't control. We don't know what it is that affects us. We can just see that we are affected, and we cannot control it. The question is, what is the reason behind this poor semen quality?
Why this poor semen quality? Why the staggering increase in testicular cancer, a rise of 400% in 60 years? And why an increase in genital malformations found in boys at birth, problems such as testicles not descending? Niels Skakovac feels that the 3 phenomena might be linked. His analysis is based on the most disturbing discovery he's made. In the cancerous tumors of adult testicles, he found cells similar to those of a fetus. It's almost as if something had stopped their development in the womb. There might therefore be a link between these different developments, those that occur at birth and those that occur at adulthood.
In Danish, you use the term "the coin fell," which means that suddenly you can see the broader picture. And with the broader picture, we could see was that testicular cancer, male infertility, undescended testes, and also some disorders of sexual development, we call it hypospadias, may all have a common origin in fetal life.
Cancer, poor semen quality, and disorders of sexual development could therefore be part of one syndrome, which Skakovac calls TDS, testicular dysgenesis syndrome. Richard Sharp has been working with Skakovac for 30 years on the TDS theory. Sharp pinpoints the origin of the syndrome as the fetal period and stresses the crucial role played by hormones during this time.
It's that layer sort of closest to the gonad.
The most important event in a male's life occurs in fetal life. I think it's not widely appreciated that each fetus in humans is really programmed to become a female. So that's what we call the setup program. Everyone will become a female. So to become a male, you've got to modify that setup program. And the first event is to form a testis. And so that's what our Y chromosome results in the formation of a testis. So that's the key event. But in fact, that still doesn't make you a male. So what makes you become a male is when those testes make hormones. And so the most important is testosterone. It's its production by the fetus, which essentially completely modifies the setup program. But I think the other thing that people need to think about is the fact that because it's something that has to bring about change, then it's, if you like, it's also risky because things could go wrong with it. So we need to be extra specially cautious about factors that may be acting in pregnancy. Because if factors cause an effect in pregnancy and affect the fetus, then that's likely to be an irreversible change.
Medical history provides us with a tragic example of what can happen when a fetus is exposed to external factors. Distilben, prescribed widely in France from the 1950s to the 1980s, was a synthetic female hormone. Chemical estrogen, in other words. Marketed as a miracle cure supposed to prevent miscarriages, Distilben was taken by over 6 million women. But the miracle became a nightmare. On reaching adulthood, people exposed to it in utero developed malformations of the reproductive system, sometimes even cancers. It was a nasty shock for the doctors. It was the first time they were confronted with the long-term effects of a chemical molecule. It was the mothers who had taken Distilben, but it was their children who were the victims. If a synthetic hormone like Distilben could have such a profound effect on the reproductive system of those exposed to it in the womb, could there be other molecules with similar effects? For example, could the mothers of the young Danish men seeking hospital treatment have also been exposed unwittingly to some danger from the outside?
It has to be a genetic cause or environmental cause. No other possibilities. And such a dramatic change in disease pattern over such a short time can only be due to environmental factors, including lifestyle.
If the environment is the guilty party, where is this silent menace hiding? Interestingly, research into wild animals brought up similar questions to those being asked by the Danish researchers. For 20 years, Lou Gillette has been studying alligators living in Florida's lakes. Before it turns into the ferocious, frightening beast that rules these waters, the alligator is a fragile creature,
02,
protected by nothing more than a thin shell.
81.
It was while observing these eggs that Lou Gillette realized that an insidious evil was undermining the realm of the alligators.
You did?
Yeah. I think one of the biggest surprises that we had when we started this work in the late 1980s was that so many eggs that we collected from what appeared to be clean, healthy lakes died. 50% of the eggs that we collected never produced a viable offspring. They were either infertile or the embryo had died early in embryonic development. We had no idea what caused this death. And one of the things that we also found were abnormalities of the reproductive system in hatchlings. And one of our concerns was this only a problem for newborn animals, or did this persist in life?
To find out, young adults had to be captured at night when they're most active. Lou Gillette took newly hatched alligators suffering from abnormalities and measured their level of testosterone, the famous hormone vital to the male's proper development. The level was abnormally low. Can a male alligator develop properly with such a low level? Along with many other tests, Gillette measured the young alligator's penis size. He was surprised to find that half of the male alligators in Lake Apopka had penises 25% smaller than usual.
From our perspective as scientists, low testosterone implied not just small penises, but many, many things, probably change in behavior, change in secretions of other organs all over the body. So for us, it's one data point. Of course, for the public, small penis size became probably the most famous finding that we have. And it's also become a bit of a joke because people can talk about alligators with little penises, but it's not a joke. It's a serious endpoint, which implies to us that these animals are seeing a lifelong abnormality in their hormones.
Is it due to a change in food, to a change in temperature, to pollution? Lake Apopka, one of the lakes with a high incidence of affected animals, had been contaminated by insecticides several years earlier. But according to analysis, the water was now clean again. Why then was the lake's current population still suffering several years after the fact?
The moment that I realized we had something unique was I was sitting in a conference listening to Professor Howard Byrne give a talk about DES daughters, DES mice. And when he showed those slides of the ovary, I realized that the abnormalities that he had in the mouse that were similar to the abnormalities in the human female, the little girl that had been exposed to estrogens, were identical to the abnormalities I had in my alligators, that had not been given a drug, that had not been given estrogen that I knew of, but had the exact same abnormality. And at that moment, I realized that we had this incredible similarity. I mean, it was the same pathology. And then the question was, well, where in the world were my alligators getting estrogen from?
Gillette found pesticide residue stored in the animals' bodies. Could these pesticides have an effect similar to estrogen, the female hormone?
We actually know what kinds of chemicals are on the contaminated lakes, so we take clean eggs, eggs from our best lakes, and we treat them. And then we ask, okay, by applying these chemicals to these eggs, can we cause the abnormalities that we actually see on the contaminated lakes? We can show by giving these compounds that we can alter penis development. We can show that we've altered the development of the testis. Or if we give estrogens at very low levels to the females, we alter ovary development. I think for me, these observations that you could expose a developing embryo to low levels of chemical is the reason why I became so concerned.
If certain man-made chemical products have an effect like hormones, the consequences would be far-reaching. Throughout nature, there are traces of various kinds of contaminant. Could they have been having an effect on the entire ecosystem? Tyrone Hayes is a world-renowned amphibian expert. Frogs live in very varied environments: swamps, streams, rivers, in conservation zones, but also in areas of intensive agriculture. At the request of the pharmaceutical and chemical group Syngenta, Hayes tested the group's best-selling herbicide, atrazine, on frogs throughout the world. In his laboratory at Berkeley University, California, Hayes exposed tadpoles to very weak doses of atrazine, doses identical to those found in the environment.
When we first did the experiment, my laboratory technician would come to me and say, "Oh, we got this result." I said, "I don't believe it." And then, I cover up all the IDs on the slides and go, "Do it again." So he doesn't know which ones he's reviewed before. And he does it again. I go, "Oh, he can do the same thing again." Then I get another, maybe student, go, "Okay, analyze this and tell me what you get." And you get the same answer over and over again, then you start to believe it's real.
Males exposed to atrazine became hermaphrodites, their testicles containing eggs. The study was picked up on by the New York Times, setting off violent controversy because the weak doses used by Hayes were supposed to have been harmless. Syngenta contested the findings and withdrew their funding for Hayes' research. While other researchers tried to duplicate his experiments in the laboratory, Hayes continued his research in the field. The worldwide population of amphibians is on the decline, with almost half facing extinction, and no one really understands why. Having waded through thousands of kilometers of water in hundreds of ponds and streams, Tyrone Hayes has come up with some clues.
Go slowly, very quiet. There's no jumping in. Catch! Catch.
Catch.
Male.
He collects frogs from all over, taking samples. He compares clean and polluted zones, trying to establish correlations between the degree of pollution and abnormalities.
I would never say that atrazine is the sole cause of amphibian decline, but pesticides have a critical role, maybe not all, but in many amphibian declines, I believe that the data suggests that exposure to pesticides can make you more vulnerable to reproductive abnormalities. If you're exposed to a pesticide mixture that prevents metamorphosis and your pond dries up, directly you die because the pond dries up. But the reason that you didn't metamorphose and escape the pond was that you were exposed to pesticides that inhibited your metamorphosis. I believe we have very good data now that exposure to pesticides causes immune failure.
Frogs, alligators, but also turtles, fish, birds. Observers of wildlife everywhere are discovering deficient sexual organs, falling fertility rates, behavioral disorders. In the animals affected, hormone concentrations are abnormal. It's as if the endocrine system has been besieged by chemical molecules.
When we think about endocrinology, and we think about how the system works, we talk about lock and key. The receptor is the lock, and the hormone, the chemical, is the key. And one of the things we're starting to realize is that we used to think that the key had to be exact. Like all of us carry around a key, we hope that nobody else has the key to our house or our car. But what we're starting to realize with endocrine disruption is that there may be hundreds of keys that can interact with this lock. And that's a little scary because sometimes it actually can make this lock do things which are abnormal. That is, the cells can be abnormal, or it can actually mimic kind of our normal key. That is, it actually can mimic a function in the body which we hoped wasn't happening.
Could the declining numbers of many animal species to some extent be due to the effect of endocrine disruptors? More and more studies are suggesting that this is so. And all over the world, men and women are exposed to the very same products.
Although we might think so, humans aren't all that different from the other animals around us. Many of the genes that regulate our development, whether or not we grow an arm or a leg or an ear, are the same genes that are regulating those events in birds, in turtles, you name it. And in much the same way, the hormones that we produce, testosterone, estrogen, thyroid hormone, corticosterone, those same hormones are produced in fish and frogs. And so if you see effects in one type of wildlife, why wouldn't you expect that those same effects would occur in humans? The exposure might be different. We don't swim in the water like a fish, but we might drink that water.
Since she confirmed Skakobak's work on decreasing sperm counts, Shanna Swan has been doing research into the possible causes of this phenomenon. If the environment does play a role, she thought, then geographical differences must exist. So she picked 4 towns, 2 megalopolises, New York and Los Angeles, and 2 cities in rural zones, Minneapolis and Columbia. She'd compare the semen qualities of the men living in these cities.
I thought people in the country, I mean, the sort of idyllic, pastoral, scene should be very safe and healthy. And then the big, dirty city stress and so on should make things bad. That was my prior hypothesis. But it was the reverse.
The men living in the urban zones turned out to have higher sperm counts with livelier sperm than men living in Colombia in a rural zone.
And then we asked, what is it about central Missouri that's different from Minneapolis, which is a big city? We suspected agricultural chemicals because in Missouri, there's more than half the land was farmland. In Minneapolis, almost none of the land around the center was farmland. So that was one big difference. And so we said, could it be something in the environment from these chemicals used on agriculture that could be responsible? We had collected urine from the men when they gave their semen sample. And so with the urine, we could look at pesticides. And what we found was that in Missouri, where the men who had worse semen quality had higher levels of agricultural pesticides compared to men who had good sperm quality.
For years, pesticide residue has been the main target of research into endocrine disruptors. But is it solely responsible? The answer would come, as is often the case in science, in an accidental way. This accident would show that endocrine disruptors have invaded our daily lives and taken up residence where nobody would ever have dared imagine. Ana Soto and Carlos Sonnenschein are biologists doing research into the lineage of cancerous cells. To cause such cells to proliferate, they exposed them to the female hormone estrogen. One day, even the control cells, those that hadn't been exposed to the hormone, started to multiply.
It looked like all the cells were exposed to hormones, even the cells that we haven't exposed to estrogens voluntarily. We couldn't understand that, so we repeated the experiment and we obtained the same result. And so we started to suspect that something wrong was going on.
It would take months of research to find the key to the enigma. The contamination came from a plastic tube. The plastic, a supposedly inert material, contained a component which had an effect like that of female hormones. It was this that set off the proliferation of the cancerous cells.
First of all, we were surprised. Second, immediately you think of the consequences of that. For example, well, if it's in the plastic, in my labware, it could be in baby bottles. And then it means that if that was the case, babies were exposed to hormones.
Detergents, tin cans, plastics, various wrappings. Soto and Sonnenschein tested the components present in 50 or so products in everyday use. In the products, they found chemical molecules with hormonal effects, like bisphenol A and nonylphenol, although admittedly in very weak doses. Too weak to have any effect, claim their detractors. For there's a golden rule in toxicology: the dose makes the poison. In other words, a product only becomes toxic beyond a certain limit. Under that, the product is assumed to be harmless. But many researchers believe that this rule does not apply to endocrine disruptors. According to them, it's not so much the dose that counts as the timing and duration of the exposure. Soto and Sonnenschein then decided to conduct an experiment with bisphenol A, an inert component found in plastic. They'd expose female rats to it while they were in gestation. A cannula inserted into the animal's back acted as a drip for the chemical molecule for 2 weeks. Soto and Sonnenschein wanted to see if the babies thus exposed to an estrogen-like molecule would show any sequels at birth, and then later in adulthood. The results exceeded their gloomiest predictions.
These rats, when they reached early adulthood, developed preneoplastic lesions. 100% of the rats developed preneoplastic lesions at all the doses we tested, even at low doses. And I asked the question, does breast cancer start in the womb? We are not proving that one thing is the cause and the other is the effect. But that reinforces the hypothesis that has to be tested. Are these xenoestrogens that have been introduced in the environment during the last 50 years the cause of this sudden increase in breast cancer incidence?
No one can explain the huge increase in the number of cases of breast cancer. 1 woman in 20 was affected in 1960. 1 woman in 8 today. With this type of cancer, which is especially sensitive to hormonal variations, the endocrine disruptor thesis is a possible lead to follow-up. In fact, many chemical products with a hormonal effect can be detected in human blood, and advances in detection techniques means that it's now possible to measure to what extent these molecules are present. Among the prime suspects are the phthalates. Used to make plastics more flexible or as a perfume binder, they're found in cosmetics, furniture, food packaging, PVC, toys, t-shirts. In the modern world, it's next to impossible to avoid exposure to phthalates. Some of them have toxic effects as regards reproduction, as Richard Sharp knows only too well. He uses phthalates in his research into the development of male fetuses. He exposes gestating rats to phthalates and observes how the little males develop. His findings have reminded him of the abnormalities in young Danes as described by Skakeback. For the rats exposed to phthalates in utero are born with genital malformations, and they have a lower sperm count in adulthood. Sharp has managed to duplicate in living animals the syndrome observed in humans by the Skakeback team, the famous TDS.
Our results produced the best verification of the TDS hypothesis, because they say that you can create it in a normal animal if you have exposure to environmental chemical, and that when you do expose to this, you create a syndrome of disorders that is very similar to what we see in the humans.
If large doses of phthalates can have such effects on rats, what can we expect from the smaller doses to which humans are exposed on a daily basis? In Copenhagen, a study was launched 10 years ago. 2,000 women were observed during their pregnancy. Blood samples were analyzed for the level of phthalates, but also of other known endocrine disruptors like pesticides or flame retardants. By means of regular consultations, the Danish doctors attempted to establish a link between the mother's exposure to chemical products and the development of their male offspring.
What was a surprise when I read Richard Sharp's results was that what happened in rodents fitted with the clinical work I'm doing. That was a surprise to me, that it fitted so well. If I look back at the history of my cohort study, I found more than I thought I would find. For one thing, I found all the chemicals in the breast milk that I looked for, and I found many associations between cryptorchidism and these chemicals, or between hormone production and these chemicals. So I am not in doubt that the human body, the human testis, is vulnerable to these chemicals. We want to follow these children through puberty and see what happens in puberty when all the hormones have to get active again, and hopefully we see them when they're big enough to give a semen sample, if it has also an effect on semen quality. That's the fear we have, that the effects we see now will actually last throughout your life, that they will have an effect also on adult function of these boys.
On the other side of the Atlantic, Shanna Swan too was measuring the exposure of pregnant women to phthalates and then examining their children. She had the original idea of applying to humans a test commonly carried out on rodents, but never previously on human beings, measuring the anogenital distance. In humans, just like in rats, this distance is on average twice as long in males as in females. Any reduction in length could be a sign of feminization.
In rodents, this distance, this anogenital distance, is what they call a marker. It tells you that there has been something that has affected the testosterone, fetal testosterone. And so because these phthalates have been shown to affect fetal testosterone, we hypothesized that in humans that would also be the case, and that the boys would have a shorter anogenital distance. And that is what we saw. We found a shorter anogenital distance and a smaller penile size in boys whose mothers had higher levels of some phthalates.
The result of this research, done on a small number of mothers, are still for the moment contested. It must be repeated by other researchers. Another challenge is to find out just how phthalates end up in human blood.
We have never measured on a biological matrix, that can be breast milk or blood or urine, where we could not measure phthalates. We have never seen a person who was not exposed. So everybody are exposed to phthalates. A major source of some of the phthalates are from cosmetics. The lotions that every woman I know put on the skin every morning.
But where do the phthalates found in certain cosmetics come from? And do they remain in the body, or are they soon evacuated? To answer these questions, Skakebak's team carried out an experiment that had never been tried before. For 2 weeks, they covered 26 young men from head to toe with cream. For the first week, they used a basic neutral cream. For the second week, it was the same cream, but with the addition of 2 phthalates and a widely used paraben. After application of the cream, the researchers took blood samples to measure the hormone levels, as well as phthalate and paraben residues.
You have to consider that if you don't want to eat it, you should not put it on your skin, because it will incite you. If you put some lotion on your skin, you can try and put some on the table at the same time. Then it will stay on the table. It doesn't evaporate or anything. After 10 minutes, you still have a drop there, but when you look at your skin, it's gone. Where did it go? It went into you, of course. Couldn't go anywhere else. So when you put a cream on with phthalates, those phthalate ends inside you, and it will give you a huge peak in your blood with phthalate, because you put it on your whole body and it goes into you and it goes into the blood.
Traces of phthalates were found in the blood only 1 hour after exposure to the cream. Metabolites like this do disappear after 24 hours. But if the cream is used every day, the exposure becomes permanent. The evidence was starting to pile up, and unlike other countries which seem prepared to wait for clear and categorical proof, Denmark decided to act. In 2006, it launched a prevention campaign aimed at pregnant women. As a precautionary measure, the Ministry of the Environment advised all mothers-to-be to avoid exposure to certain products like cosmetics, hair dyes, paint. A 9-point warning was distributed to every maternity ward in the country.
I think that there's more and more evidence that adult disease may have the origin in fetal life. It's not just testicular cancer. There are other types of diseases also. A metabolic syndrome. It's something that we have to learn, that is extremely important, that we take good care of our women.
The scientific community was starting to arrive at a consensus. It's in the first moments of life that the environment can have an effect by disturbing the sensitive hormonal balance. It would seem, in fact, that it's during pregnancy that various pathologies are created, such as cancer, diseases of the immune system, thyroid problems, diabetes. The list of potential evils just keeps growing in international publications. Niels Gakkeback remains on the lookout for any sign of hormonal abnormalities in society. And a small newspaper article caught his attention. Teachers at the Royal Copenhagen Choir were noticing to their annoyance that young singers' voices were breaking increasingly early. Was it some sort of precocious puberty? Danish doctors took yet another innovative turn by taking the age at which the voice breaks as a possible marker of masculine puberty. In Bach's time, this music was sung by young men of 17 or 18. Today, this is impossible because the voice breaks at around 13 or 14. Using school registers, doctors have discovered that in 10 years, the average age at which the voice breaks has fallen by 4 months. By keeping track of the young singers, they hope to ascertain whether the tendency is continuing and if it's yet another syndrome of hormonal disorder, this time affecting adolescents. For 10 years now, an increase in research, with new suspects being outed all the time, has forced chemical companies to take steps. Backing up some studies while withdrawing funding from others, they keep up with every new publication. David Cadogan represents the European phthalate industry. He's in Copenhagen to take part in a symposium organized by Skakkeback and his team. This symposium takes place every 2 years. It's an unmissable event for everyone working on endocrine disruptors. Over the years, the gang has got bigger, the pioneers being joined by new iconoclasts.
Will breast cancer incidence be found to be increased in women exposed in utero to BPA 25 years from now? And what we should do in between?
Right, so I'm going to be talking about an animal model, and just to remind you really that the objectives of developing an animal model is to enable you to ask questions about human disorders that is impossible to ask in a clinical situation.
Aren't you too anxious about what you've heard today about phthalates?
No, I'm not, because we're still talking about effects in rodents, and I believe when we have all the information that we will find these effects are not relevant to humans.
Has been written by Jerry Heindel as a workshop for...
The industry's representatives keep themselves informed about all the latest research. In this way, they hope to second-guess future conflicts and the possible problems related to the banning of various products. For the moment, their strategy is to contest the findings, fuel any doubts, stall for time.
So I talked to the phthalate toxicologists we know here and colleagues and said, what do you measure? What do you see? What should we measure? Because we don't know how this dysmorphology would manifest itself in humans if it existed. And we put together this exam. So we measured the anogenital distance.
For the first time, an effect has been observed on humans.
Exactly. I am not worried because I do not believe the data. I believe there are some fundamental flaws in her experimental technique.
This is not a surprise. This is what industry does to counter science that they don't like. It's their job. That's his job to criticize me, and my job to do the best study I can.
No, I haven't got a film, no, sorry. No.
I definitely feel I belong to a community. I even tell people this is my scientific family. We were actually attacked as, what did they call us? Endocrine disruptor crybabies, or truth disruptors. We need to support each other because it's not a field that's been accepted in the broader scientific community very easily. We are now growing in acceptance, and it's becoming much easier. But for a long time, we had to hold on to each other for support because we were under attack.
The effect of endocrine disruptors has become a major issue for public health. Caught between scientific data and industrial lobbying, the debate has now entered the political arena.
The possible consequences of endocrine disruption are of great concern. The cost of inaction for endocrine disruptors in terms of human and environmental health now and in the future may run very high. It may very soon be about time to call the precautionary principle to the mind of colleagues. Please, I ask you as scientists to give us the tools we need to take effective action.
How best to protect people from chemical substances? In December 2006, the European Parliament adopted a new regulation concerning chemical products, the REACH Directive. Over 11 years, 30,000 substances, including of course endocrine disruptors, will have to be registered. The directive has made it the responsibility of industrial concerns, and not of public authorities, to prove the harmlessness of their products. With this new restraint unique in the world, REACH represents a turning point in the regulation of chemical products. But it remains to be seen how it will be applied. Backed up by a powerful lobby, the chemical industry has won a few victories. It can, for example, obtain permits for using dangerous chemical products if it proves that it can control the risks. Risk control is the unshakable belief of the industrialists. For every piece of research that shows the hormonal effects of certain molecules, the industrial lobby, displaying the benign calm of a responsible parent, counter with other studies.
So what would you answer to people who are concerned?
I would say they can, or you can be reasonably certain that the products that are currently on the market have been assessed under the question of endocrine disruption and can be used safely for you and for your children as well.
Still in 2005, 6 phthalates considered toxic for the reproductive system were banned for use in toys and childcare articles by the European Union. It's a decision which the industry claims is more political than scientific.
The Parliament took a policy decision, very much on the precautionary side, which we accept. However, we still think this is much overdue and causes more concerns in the public than safety. Because if this is a way we assess substances in the future, any assessment under REACH, which is scientifically sound-based, can be politically overruled. And I don't think it's a liable way to go forward if Europe wants to be an innovative region in the world.
The industrial concerns are fighting every inch of the way, defending each molecule in its turn. But is this really the main issue today? Every human is exposed not simply to one single molecule, but to a whole cocktail of molecules. What is the effect of this cocktail? In one of the largest animal houses in Europe, a Danish team undertook an immense job, exposing 1,200 rats to a low-dosage mixture of 3 molecules, a phthalate and 2 pesticides. The females were fed during their gestation, and the offspring examined all the way until adulthood. The results seriously overturned common mathematical rationality.
Our results illustrate that 0 plus 0 plus 0 can give 7. And that means when you have 3 chemicals, you would say chemical number 1, this is a 0 effect level, no problem. The same for chemical number 2, the same for chemical number 3. What our results are showing is if you have a mixture of chemical 1, 2, and 3, you have clear effects. What was a really big surprise was that the males actually didn't look at the high doses of the mixture. They didn't look like males. They had a very high frequency of malformations, and on some endpoints they actually looked a lot like females. We were so surprised that we hadn't expected to see it that bad. My main message would be that risk assessment without considering mixture effects underestimate the risk to humans.
There is no legislation in place anywhere in the world that adds up the contribution from different compounds. It has all been made one compound at the time. And it has worked so far, there's no argument about that. But it is starting to break down because the number of compounds is so high now that we can no longer say you can look at them one at a time. It doesn't work. It's starting to break down. There will be some scandals coming. I don't know when. It could be tomorrow, it could be in 5 years, but there will be examples where the combination of 1,000 compounds at a very low dose exceeds what we can repair in ourselves.
In this world of invisible threats, a story about whelks provides an optimistic note on which to close. It proves the effectiveness of when scientists' warnings are being heeded and shows that it's never too late to act. 20 years ago, biologists were alarmed at the progressive decline of the whelk population. The reason for the decline? They discovered females with penises.
Okay.
In the great free-for-all of sexual aberrations that nature has become, the biologists called this an imposex. Where did this imposex come from? In the chemical cocktail that was home to the whelks, research managed to identify the culprit, a component of anti-corrosion paint used on boats, TBT. Battle then commenced to save these enigmatic sentinels of our seashores, the whelks. In the end, the European Union banned TBT in 2003.
Unmittelbar nach diesem Verbot, mit einer Verzögerung von einem Jahr, sehen wir jetzt an allen Untersuchungsstellen, die wir hier in Frankreich haben, einen dramatischen Rückgang der Belastung. An Standorten, wo früher keine Reproduktion, keine Fortpflanzung möglich war, treten jetzt plötzlich wieder Eikapseln auf. Das heißt, die Populationen verjüngen sich selbstständig. Und das ist eigentlich ein Zeichen der Hoffnung. Und es zeigt vor allem, wenn wir einmal den Mut aufbringen, zu reagieren und notfalls auch mal eine Substanz zu verbieten, wie schnell dann letztlich die positive Wende zu erreichen ist.